Similarly, you've got another model of power transmission. This time you have been told about the resistance. Voltage is here, is AC. What else? Important. V is here. Yeah, nothing else. Each of them 3 ohm. That's it. Part A. The generator actually generates a much lower voltage than 2000. So that's why how this voltage is increased. So suggest how that is the method using step-up transformer. I think that's good enough. State 1 advantage. Again, similar to the previous. So I'm not going to write again. So again, in the power cable. Part B. Power delivery is this one. Calculate the current in the transmission line. So similarly, you have got the P equals VI. Yeah, that's correct. This side is a B, so the answer is 2.5. And lastly, calculate the rate of lost energy because of this. So, like previous question, you will use I squared R for power loss in the cable. Because you do not know V, remember, you don't know V. So use this equation, 2.5 squared times 3 because it's 3 ohm. And also the question said one of the lines, so 3 is fine. If you do 6, then it's too much. So, is that the answer? 18.75.
Yes.
Yeah, thank you. The unit is what? Angus, the unit is what? Is what? Is what? W. Oh, actually there are two more parts. Now calculate the voltage drop of the transmission line. So you could use V equals IR, which is good. And you find out it drops 7.5. But this is not realistic because the resistance is too low. I don't think it could be that low. E. Potential difference V at receiving end. So you simply minus 7.5 twice because you have got 2 transmission lines. So that's basically it. Very simple, right? Much easier than the one we did. Because you have got 2 cables. Each of them drops 7.5. Yeah, so you minus twice. Yeah, because it's both cables. Any questions?